Okay, so lesson 6-9, we're going to be looking at graphing linear inequalities. So we've been looking at equations of lines. We've looked at all the different forms. And now we're going to look at linear inequalities. So think about the inequalities, the less thans and the greater than. What are they going to look like on a 4-quadrant graph? Okay, so your big idea, the two sides, which we call half planes, of the line with an equation ax plus by equals c, so your standard equation of a line, can be described by the inequalities ax plus by is less than c and ax plus by is greater than c. Okay, so we know that not every problem in the whole world has one answer. It can be everything less than a number, it can be anything greater than a number, and this also applies to these lines on a graph. And we'll talk about what situations they could represent later. So our quick definitions, our boundary line is going to be the actual line on the graph, and it's going to split our graph into two pieces. There's going to be the area that's above the line. So if there was a line on this graph, there's going to be an area above it that could be part of the solution set, and there's going to be an area below it, which is like the less than, that could be part of the solution set. All right, and the boundary line is just the actual line itself that's going to have an equation that splits it. Now the half plane, the regions on either side of the boundary line. So we actually call a graph a coordinate plane. Okay, it's a flat plane. And so a half plane is just when we draw a line and we cut it into two pieces. And we're talking about either the top part or the bottom part. So that's your half plane. And when we say linear inequality, okay, when we talk a linear equation, it's an equation that forms a line. So a linear inequality is when we have not an equal sign, but a less than, or it could also be a less than or equal to. Now, when we put these lines on the graph, it's very important that sometimes we're going to have to put a dotted line to show that it's not included. And sometimes we're going to have to put a solid line when it is included. If you think back to when we were doing our just little line graphs, when we saw a less than sign, we put an open circle because the point itself was not included. So when we're talking about the equation of a line or this linear inequality, when you have something with no equal sign, that's going to be a dotted line when you draw it on the graph. And when we looked at our little line graphs and we had a less than or equal to or a greater than or equal to, we filled in the circle because that point was included. So now we're talking about lines, and so we're going to put a solid line to represent this type. So when you look at a graph made by somebody, you should know if it's a less than or greater than, or if it's a less than or equal to, or greater than or equal to. Dotted line means it's not included in the solution set. Everything below it may be in the set, or everything above it, depending if it's less than or greater than. Or you could have a solid line, and that means not only is the top or bottom, whatever's shaded, and we'll get to that in a second, not only is that included in the solution set, but the actual values that sit on the line itself are also included. All right, so let's take a look. We're going to start off with some real basic ones. So we're looking at the inequality y is less than 3. So first thing I want you to do is graph the line. And you're going to pretend like it's an equal sign. If we had y equals 3, what does that line look like on the graph? So we've talked about anytime we just have a y equals or an x equals a number, that's either a horizontal or a vertical line. So if it's y equals 3, that means everywhere we go on that line, the y value is 3. So let's go to the y-axis and find that 3. And we're going to draw the line that always stays at y equals 3. So even if I go to the right, it's up there. Even if I go to the left, that line's going to be there. Now, before I actually physically start drawing that line, I need to go back. I need to look. Should it be dotted or should it be solid? So there's no equal sign. So this needs to be a dotted line where I would have y equals 3. So part 2 would be to choose dotted or solid. And now we're not done yet. Just like when we put inequalities on a single line graph, we had to shade one side, everything less than, everything greater than. The same is true on one of these graphs. Okay, so we have to choose to shade either above it or below it. So either all of this region up here is part of the solution set, or all of this region down here is part of the set. So you simply just read it. It says y is less than 3. So it's all the answers less than, which would be under. And so you're going to shade all of this region in. And what you're saying is, I can choose any of these points down here, okay, whether it's 2, 1, or whether it's 5, -5, or -3, -4. All of these points are going to make this equation true. Whereas the opposite, if I choose a point up here, like 5, 5, that is going to make this equation or inequality untrue. So everything in the shaded region is a possibility. Everything above the shaded region is not an answer. And remember, since this line is dotted, that means any point that actually sits on this line is not part of the set. It is not going to make this true. Okay, because if you chose one of these numbers, the x value is something and it doesn't matter because there's no x here. And the y value is 3. So if you replace 3 in for y, it's going to say 3 is less than 3, which is untrue, which is why this line is not part of the answer. So let's look at one that has an x by itself instead of a y. So let's pretend it said x equals -2. Think about what that would look like. It's the line that's always at x -2. So x -2 is right here. And so it's the line that even if I go up and change the y value to a positive or to a negative, the x value stays -2. Well, I forgot to put step 3 over here, would be to shade the correct half plane. So coming back here, my point x equals -2 is here. The line would be straight up and down, a vertical line. Now, this has the equal sign. So this is a solid line. It's going to look like what we're used to putting. A nice solid line. And now we have to choose, is it going to be the left side or the right side? So normally it's just above it or below it, because every line that's diagonal or straight across horizontal here is going to have like a bottom and a top. But this is like the one case where it's straight up and down, so it doesn't have a bottom and a top in terms of the regions. But left would be less than, like we're used to on a line, and right would be greater than. So when we go to shade this, it says x is greater than -2. And so that's going to be the entire region to the right. And again, we want to understand what we're doing, not just, okay, it says greater than, so I shade the right. Cool, I got the answer right. But what does that actually mean? That means any point that I choose in this shaded region, if I plug in the values, it's going to make this true. Any point that I plug in from the unshaded region is not going to work for this. And since this line is solid, if I plug in an ordered pair directly from this line, it's going to work because this is part of the solution set. So it's just like choosing something from the shaded region. So let's flip it over and take a look at some other types of lines that aren't simply these horizontal and vertical ones. So example number 2, same idea, just different forms of these inequalities. So if we take a look at this one, it's still going to be the same steps. So think about if it just had an equal sign. What would that look like? So we spent a lot of time looking at this is the slope and the intercept. So we can put this right onto the graph. And let's just think about it ahead of time. When we go to put the line, okay, it's going to be a dotted line because it is not included in the solution set because it just says less than. And thinking ahead, since it says y is less than, we're going to shade the region that's underneath of it. So we know the y-intercept is 3, so we're going to go up to 3. And we know that's a point that's going to be on this line. And the slope now is -2. Which is down 2 over 1 because it's like -2 over 1. So from here, we're going to go down to over 1, down to over 1, all the way down, following the pattern. We can even go up to left 1. Always double check your line. It's supposed to have a negative slope. So as we go from left to right on that graph, it is going down. So we know that's good. And when we go to connect it again, this says less than. And so it's not going to be included. So what we need to do is draw a dotted line. And again, since it says less than, we want to go underneath of this, which is always to the left as well. And so the shaded region on this one is all of this. So going on to the next example, we've got a greater than sign. Okay, so think we're going to shade above the line, and there's no equal sign. So when we draw the line, it's going to be dotted. So again, if it helps, think about it just as an equation. We know the intercept is -2, so it's going to hit the y-axis here at -2, and the slope is a positive 1/4. It's going up because it's positive, up 1 over 4, and we're going to make a dotted line. So up 1 over 4. The next coordinate is not going to be on the graph, so let's go backwards. Instead of up 1 over 4, down 1, left 4. There's that point. And when we go to draw this, it's really easy to just get in the habit of drawing that straight line. Solid, but this is going to have to be a dotted line. Okay, it's dotted because it just says greater than. It is not part of the solution set. So only everything greater than this line is part of the solution set. And so it's pretty obvious on this one. That would be all of this region. So any point, any ordered pair, so 0, 0, is going to make this true. Think about it. Here's 0, 0, should be part of the solution set. Plug it in for x and y, 0 and 0. This 0, when you multiply times 1/4, makes it go away. And so all you're left with is a -2. This y became a 0. So it says 0 is greater than -2. Well, that's a true statement. Okay, so this point of 0, 0 makes it true. And that's going to be true for any set of points that you pick up here. If you picked a point that's actually on this line, it's going to make it untrue because it's not included. And if you pick a point that's in the non-shaded region and plug it in for x and y, it's also not going to work. All right, let's look at one special case down here, and then what happens when we have an equation that's not in a nice form. So starting here, it's first of all says less than. Okay, so we're going to be shading underneath of this line, and there is an equal sign there, so it's going to be a solid line. So think if this just said y equals 2/5 x. It does not appear to have a y-intercept, but it technically does. It's like a +0 being out there. So the y-intercept is 0. It's going to hit right in the middle of that graph. So if there's no plus or minus, our intercept is 0. It's a positive 2/5, which means we're going up 2 over 5. And if we want to go backwards 1, down 2, 5 this way. Again, it is included because of the equal sign, so we can draw a solid line. Anything on this line will work for this inequality. Take 0, 0, for instance. Plug them in. 0 on this side, when you multiply, it gives you a 0. You already have a 0 on this side, so it says 0 is less than or equal to 0. So it's the equals to part that falls on this line. Now, it says y is less than. So all of the rest of the solution set is less than or underneath this line. So any point in this shaded region is going to work if you plug it in. Okay, let's go to this last one now. To put this on the graph, the easiest way to do it is to have one that's in this slope-intercept form. So what we're going to do is we're going to go ahead and we're going to take this and we're going to have to solve it for y so that it says y equals, and then it looks like the rest of these, and we've got a nice slope and intercept. So we're going to take 2x minus 3y. I'm just going to bring it down here. So I've got some room to work with. I'm going to solve it for y. So minus 2x. And then all I got to do is divide by -3. Now I want to stop you for a second and remind you, when you're working with inequalities, if the number that you're dividing by is a negative, think about what you have to do. You have to flip it. So that doesn't change. That's still true here. So this cancels and I still have just y now by itself. Since I divided by a negative, this must flip the other way. And think about how important that is. Here, it's going to tell us to shade the exact opposite region. So if you forgot to flip it, you're going to end up shading the wrong part of the graph. 2 negatives over here do make a positive. So it's 2/3. Oh, and I had forgotten over here the plus 12. Some of you are probably thinking, what happened to the 12? So it was a negative 2x. We still need that plus 12. All of it gets divided by 3. So over here, 2 negatives make a positive 2/3. x. Now this is plus, but when we do 12 divided by negative 3, that's negative 4. So we're going to minus 4. And now we have an equation or an inequality that we can work with. Here's our slope, and here's our y-intercept, negative 4. So I'm going to go to negative 4 and put it on the graph. I'm going to use my slope of 2/3 up 2 over 3, up 2 over 3. Go the other way, down 2 over 3. Notice I made a solid line because there is an equal sign here. Even if it flips, that's not going to change. I still have the solid line because the equals is there. And now I got to choose, am I going to shade underneath or am I going to shade above? Where's the solution set? So if you just looked at the original and you saw y on this side and you saw open towards y, you might initially think it's going to be above. But you can always double check. If the coefficient of y has a minus in front of it or it's a negative, you know you're going to end up dividing by that number. We ended up dividing by negative 3, which flips it. So if you're going to check at the beginning and start thinking ahead, is this going to be shaded above or below? All you have to do is look at the coefficient of y. If it's negative, this is going to flip and it's going to end up saying less than, and that's what happened. Okay, so you can even understand that ahead of time. You don't have to go through the whole process to see that. But y is less than, and so the region that we need to include in this solution set is completely underneath.